The first is IVT, intermediate value theorem. So let me see if I can explain to you basically what IVT is. Let's say, I have my little meter stick here. Let's say I go from 30 centimeters to 80 centimeters. And the function is continuous. So that means at some point I had to go through 60. Right? And at some point, if I go from 30 to 80 and it's continuous, I also have to go through 50. I have to go through every point between those two things. That's basically what the intermediate value theorem says. Okay, so here's the formal definition. It says the intermediate value theorem, IVT. If y equals f of x is continuous at every point of the closed interval, then for every d between f of a and f of b, there exists a value c in between a and b such that f of c is equal to d. Okay, so let me translate that for you. Basically what it says, if the function's continuous and it goes from one endpoint to the other endpoint, it's got to pass through every value in between those two endpoints. Okay, so let's say that I'm driving down 75, again, in my Ferrari. If I drive from 40 miles per hour, and then again, okay, who do I want to pick on? Amarisa is in her minivan in the left-hand lane and she's going like 40, right? And I got to pass her, okay? If it's continuous and I go from 40 to 80, at some point I went through 60, right? I was going 60 miles an hour. So the IVT basically says, if f of x is continuous from a to b, put and closed. If f of x is continuous from a to b, and the function is closed, and f of x is closed, then the function must be equal to every point between a and b. Okay, it's kind of common sense. If we're going from 20 to 80 and the function's continuous, then that means we're going through every value from 20 to 80. So let's look at this multiple choice question. It says, the table above shows selected values, so we don't have everything, of a continuous function f. For x between 0 and 13, what is the fewest number of times that f of x is equal to 4? So we want to know how many times, the fewest number of times. We can't say for sure because we don't have all the values. We have selected values. But we want to know how many times, the fewest number of times that f of x is equal to 4. Okay, well, if the function's continuous, which it says that in the stem of the problem, and we go from 3 to 4.5, do we go through 4? Yes. Well, if we go from 4.5 to 3, do we go through 4? Sure. And if we go from 2.5 to 4.4, and again, the function is continuous, do we go through 4? Yes. Therefore, the fewest number would be 3. There could be more because we don't have all the values, right? But there has to be at least 3. And you can see this graphically. I'm not going to take time to do it. But if we were to plot these values and then draw a continuous function going through all those points, there would be at least 3 times where the y value is equal to 4. Okay? So that's IVT. Questions for me?
Attendance, please.
Well, let's look at MVT. The mean value theorem. Mean value theorem says if y is equal to f of x is continuous at every point in the closed interval from a to b, and the function f of x is differentiable, meaning it has a derivative at every point in its interior, then there is at least one point on the interval from a to b at which f prime of c equals f of b minus f of a over b minus a. So this f prime is what? It's a derivative, or another way to say that would be the slope of the tangent line, or another way to say that would be the instantaneous rate of change. I like that one because I call it IROC. I do, of course, right? Instantaneous rate of change. IROC. Or it's going to be the tangent slope. Well, over here, f of b minus f of a over b minus a. This is not the instantaneous rate of change. It's the what's the type? Perfect period. It's the what is that? It's a rate of change, right? It's the slope, but it's not the instantaneous rate of change. It's the, wait for someone to say, it's the average rate of change. House average rate of change. Or, okay, slope of the secant line, or AROC, right? Average rate of change. Fall break just erases all of our calculus knowledge. Okay, so hold on. Here's what mean value theorem says. If a function is continuous and the function is differentiable on a closed interval, then at some point the instantaneous rate of change has to equal the average rate of change. So if I am driving on 75 again in my calculus Ferrari, and my function is continuous, and I average 60 miles per hour from driving from McKinney to Plano, then that means at least one time, at some point, I was driving 60. I have to be. Graphically, it looks like this. Okay, so I've got a function, f of x. I'm going from a to b. is the function, imagine that's solid line there. Is the function continuous from A to B? Yes, it is. Is the function differentiable from A to B? How would it not be differentiable? If there's like a what? Okay, if it's undefined, then it would fail the continuity test, right? But if there's like a corner, for example. Okay, so it's closed. It is continuous. The function is differentiable. Therefore, the secant line from A to B right here, there's going to be at least one point where the tangent line, we're going to call that point C right here. And the tangent line is going to be parallel to the secant line. Okay, so IVT says, switch back. IVT says if the function is continuous and the function goes from this point to that point, well, if it's continuous, it's got to go through every point between those two things. Mean value theorem says that if the function is continuous and the function is differentiable, then on a closed interval, the average rate of change, A rock, equals the instantaneous rate of change, I rock, at least once. Okay? Questions for me? Yes?
So the left side, F prime of C, that's a derivative.
Yes.
And so is the right side, correct?
It could be, yes, but those are two different things. Okay, because here at the instantaneous rate of change, I may only have one value or one time. Whereas average rate of change, I'm looking at the slope from point to point. Okay, what else? Let's look at an example. Let f be the function given by f of x is equal to x cubed plus 5x. For what value of x in the closed interval from 1 to 3 does the instantaneous rate of change I rock of f equal the average rate of change A rock of f on that interval? Okay, so can you find the instantaneous rate of change right now? Well, the answer to that is no. Because, well, let me ask you, why not? It asked me to find a value of x in the closed interval for the instantaneous rate of change, but at what point? At x is equal to what? Okay, what I can find right now is the average rate of change. So, what 2 points am I going to use to find the average rate of change? Well, they tell me this right here, this is A rock. Okay, the function's going from 1 to 3. So my x value is 1. My other x value is 3. How do I get the y value? I'm going to plug these values into the function that they gave me, f of x. So I got f of 1. It's going to be 1 cubed plus 5 times 1, which is 6. And then I need f of 3, which is going to be 3 cubed plus 15. Oh no. Math. Where have you gone? We've been on a mathematical famine. What's f of 3? 27 plus 15, which is 42. Okay, so now I have my 2 coordinate points. I'm going to find the average rate of change. So we've got 42 minus 6 over 3 minus 1. That gives me 42 minus 6 is 36 divided by 2. That gives me 18. So my average rate of change from 1 to 3 is 18. Okay, so now they want to find what value of x does the instantaneous rate of change of f equal the average rate of change. So this right here, this is my average rate of change. I'm going to take this and set it equal to what? I'm going to set it equal to, look at that formula, the average rate of change, mean value theorem says, continuous, differentiable, closed, then average rate of change equals f prime of c. So I need to find f prime. So f prime of x equals 3x squared plus 5. So I'm going to take 18, set it equal to 3x squared plus 5, and then solve for x. So I'm going to subtract 5. That gives me 13 equals 3x squared. Then I divide by 3 on both sides. And then I am going to take the square root of both sides. And so that gives me the square root of 13 over 3 for my answer. Okay. Questions for me? Already. Suppose Izzy is driving up and down Highway 75 for the same experiment as earlier in the year. Izzy's position function can be modeled by the differentiable function S of t equals E of t plus sine of t in miles for the interval from 1 to 4 minutes. If the mean value theorem is applied, can we apply it? Is the function closed from 1 to 4? Is the function continuous? Does it say it's continuous? Ah, okay. Say that louder. It's what? It is differentiable. And if a function is differentiable, then what? Differentiability implies continuity. So if a function, it says the function is differentiable, therefore the function must be continuous. So yes, we can apply it. It says find the value of f prime of c that is guaranteed by the mean value theorem if c exists on the interval for c between 1 and 4 minutes. Okay, so this right here is the instantaneous rate of change. However, we're not going to find that just yet. We're going to find what? We're going to find average rate of change because they give me the interval from 1 to 4. Okay, so I'm going to find the average rate of change from 1 to 4. I'm going to take S of 4 minus S of 1 over 4 minus 1 and get an answer. So take your little calculators. And so again, if it's a calculator problem, number 1, we are in radians. Check your mode. Okay, the AP exam, I'm going to be standing there. As you walk in, radians, radians, radians. Put your calculator in radians. Make sure you're in radians. Okay. Number 2, the second thing that we do is put the equation into your calculator. So I'm going to put E of t plus sine of t into my calculator. And then you can do it a number of different ways. You can go to the table, or you could do y1 of 4 minus y1 of 1 over 4 minus 1. But use your calculator to get that average rate of change. To do y1, you go alpha f4. And then just put it in parentheses. So it would be y1 parentheses 4 minus y1 of 1. And so check with your neighbor there to see what they got. So I got 16.761. Although it might be slightly different depending on your calculator and the rounding. Okay. However, this is the average rate of change. What are my units? What's S measured in miles? And the denominator would be it's time, so Izzy is traveling 16.761 miles per minute. He's very fast, right? Probably borrowed my Ferrari or something. Okay. So this is my average rate of change. Okay, so mean value theorem, MVT, guarantees this to be f prime of c. So part B of this says, find the value of c that satisfies the mean value theorem from part A. So notice, read carefully what they are asking. Okay. In the first part, it says, find the value of f prime of c that is guaranteed by the mean value theorem if c exists. That's the average rate of change. But here, since we're dealing with time, they want to know when, at what time exactly is the instantaneous rate of change equal to the average rate of change. So to get the instantaneous rate of change, I've got to do what? Find the derivative. So S prime of t equals, what's the derivative of e raised to the t? E raised to the t. Plus, what's the derivative of sine of t? Plus cosine of t. And so now I'm going to set 16.761 equal to e to the t plus cosine of t. And what? And solve for t. How do you do that? Use your calculator. It's a calculator problem. Okay, so put 16.761 into y2. You could graph them and find the intersection. You're probably going to have to change the window settings though, right? Because this is 16.761, which is greater than the 10 by 10 standard window in your calculator. So put your y max at 20. Check with your neighbor. Everybody know how to graph the intersection there? If not, raise your hand and I or somebody will help you.
Yeah.
So why is this?
FOC is the average, right? Because you're not doing the derivative anymore, so F is not
Mhm.
gonna be just-
So the F privacy. Right, yeah.
It's this because the theorem says that
Okay,
it's just that-
so I got 2.875 and my units would be minutes. There,
When you solve for A.
Okay. Patty, did you have a question?
On part A.
Okay.
It's like saying F privacy is that instantaneously, but your answer is the average.
Okay, because it is saying, well, in this case, if the mean value theorem applies, those two things are equal to each other.
Okay, so it's not always though, it's just if the theorem exists.
If the conditions of the theorem are met, then those two things are equal to each other.
Okay.
Got it?
Yeah.
Okay. Anything else? Everybody okay with this? We're gonna look at one more. The rate at which fuel flows into a tank, RFT, in gallons per hour is given by a differentiable function over time. The table shows rates measured every 2 hours for a given 12-hour period. So when I'm reading the stem of the problem, I'm thinking in my head, okay, what is RFT? Is it an amount? Is it a rate? Or is it a rate of change of a rate? In this case, my keen powers of observation tell me it's a rate. I could also look at the units. What are the units? They're in gallons per hour. So RFT is like, it's like a velocity. Like VT. So here we go, part A. How many instances can be shown from the data in the table that RFT equals 89 gallons per hour? Justify with a theorem. Okay, so they want to know how many times RFT could be 89. Which theorem am I using here? IVT. Okay, so let me say this. Lots of students lose points because of the justification here. So this is how you justify it. Okay? Number one, we don't use pronouns. We don't say it. Number two, we don't say the function. Be specific. What a professor in college. He would write, be specific on all the papers, then he would abbreviate it to where it would just say the initials all the way down your paper. Like, thank you, Dr. So-and-so. Be specific. What is the function? The function is RFT, okay? Since RFT is, what do we know about RFT? They tell us in the stem of the problem that RFT is, do they say it's continuous? They don't say it's continuous, but they do say that it is differentiable. And so when they're grading the AP exam, they're reading it like they know nothing. Okay? So you've got to tell them, since RFT is differentiable, RFT is therefore continuous. You need to say it just like that. Since RFT is differentiable, RFT is therefore continuous. So how many times is R of t equal to 89? Well, if the function's continuous and it goes from 88 to 92, then it has to be equal to 89 at least once there. And it also has to be equal to 89 if it goes from 93 to 88. If the function is continuous, it's also closed, right? It's going from 0 to 12. Okay, I'm gonna put and closed out here. So answer the question that they asked. What did they ask? How many instances? So 2 times by the intermediate value theorem. However, you don't have to put the theorem. You don't have to put by mean value theorem, but you do have to put this. Since R of t is differentiable, R of t is therefore continuous, so 2 times. Yes,
Right, IVT.
that's fine. Just make sure it is the intermediate value theorem. Like you can't get credit if it's the mean value theorem and you write IVT, right? But you don't have to write the theorem. You do have to write the tenets of the theorem, though. Okay, so that's the first one. Part B says, how many instances can be shown from the data in the table that R prime of t equals 0? Justify with a theorem. So what is this? This is IROC, right? This is IROC. So what are they asking? IROC is equal to 0. Okay, so they give me IROC. IROC is 0. They want to know how many times that it's equal to 0. So how would we work this problem? Let's think it through and then we can justify it. Well, we are going to use which theorem? If they give me IROC, then I'm going to use mean value theorem. And mean value theorem says what? That the instantaneous rate of change is equal to the average rate of change if the function is on a closed interval and it's continuous on that interval and it's differentiable on that interval. Okay, so I want to find when the average rate of change is equal to 0, or how many times the average rate of change is equal to 0 on the interval. So how would I do that? I'm open to your suggestion. Don't complicate it. Yes? You wanna try? Well, if I do that, if I do 88 minus 76, will the average rate of change be 0? It will not, and that's what I want. But you're kind of on the right track. Let me ask you this. What is the average rate of change from 4 to 12? At 4, what's the value of R of t? 88. At 12, what's the value of R of t? 88. So what's the average rate of change? Gonna be 0, right? You set it up, 88 minus 88 over 12 minus 4 equals 0. And so there's at least one time. And so let me state this another way. What are we looking for in order to answer this question? We would be looking for if R of t, if the values of R of t repeat, right? Is there another instance where it does? Well, maybe, we don't know. But based on the values in the table, we can only say one time. Okay, but I've still got to justify it. So here's how you justify it. since R of t is differentiable then R of t is continuous and MVT applies. You gotta have that. You don't have to have MVT, but you've gotta have that. And then answer the question, how many times? Therefore, there's a minimum of 1 time. So you can't justify anything else based on the values that they gave you in that table. Okay, so last one here. It says, find the average rate of change of fuel flow on the interval from 2 to 10. Give units. What does this value tell us in terms of MVT? Okay, so looking at the table, I've got 2, R of t is 84. And at 10, R of t is 93. It says find the A rock. So I've got 92 minus 84 over 10 minus 2. Thank you. All right, let's do some quick little math. That's going to be 9 over 8. What do I do next? What does it say? You have the units. Well, what are my units? Well, let me ask you this. What's in the numerator? R of t, right? R of t is in the numerator. What are the units for R of t? Gallon, no, look at it. R of t is a rate. Gallons per hour in the numerator. What's in the denominator? Time, which is measured in hours. Therefore, this is going to be gallons per hour squared. Because if I have a velocity and I find the slope, I'm taking the derivative, which would be like an acceleration. Okay, so what does this value tell us in terms of MVT? It tells us at some point on the interval from 2 to 10, the instantaneous rate of change equals 9 over 8 gallons per hour squared. Because R of t is differentiable and therefore R of t is continuous. End closed.